Hello, welcome to our Semiconductor education program. I'm Vincent Chang. In this video, I'm going to teach you Class AB Upstage Part 3, Short Circuit Protection. Short Circuit Protection circuitry. So this video is related to the other variation of the Class AB upstage. Remember the first variation, Darlington NPN. The second, compound PNP. Here's the third one, the short circuit protection circuitry. Why? Why we need a short circuit protection for the upstage? Because it's dangerous, right? So upstage, the mission of the upstage is to what? Is to deliver, to supply the big current to the external load. So, because the big current, so you can expect the big current is gonna flowing through its own body, right? So it's dangerous. So what if the current is too big? Or what if there's a short circuit event happen in the external load, right? So in this situation, you got to know how to protect yourself. For example, you have to put on the armor, right? If you are in a dangerous place, you have to carry a weapon, etc. So it's the same thing with an upstage. So the upstage need to protect themselves, the NPN and the PNP. So here's the protection circuitry, Q1, and a resistor, a small resistor R1. So what's the magic behind this? What's the magic? What's the reason behind this? So let me give you an example. For example, R1 is 27 ohm, and the turn-on voltage of the BJT, of the bipolar junction transistor, is 540 millivolt, 0.5 volt, 0.54 volt. So with these two data, right, what will be the maximum of current? So two questions. Number one, why? What's the magic behind this short circuit protection? Why? What, in other words, why this is the armor? When I put on the armor, then there in the event of the short circuit outside, then I won't be burned out. I won't be destroyed. This is the first question. The second question, what is the maximum of current? So now, I want you to give you 5 minutes. Okay, so this video, this lecture is kind of deeper. Okay, so do several things. Number one, you try to draw out the whole circuitry, including the short circuit protection circuitry. If you can, you go back. Number two, and think about why this is an armor. Why Q1 and the resistors serve as an armor? Number three, why? So what's the maximum of current? So let's pause for 5 minutes. Can you figure this out? Not easy, right? It's not easy. Let me answer the maximum load current first. Maximum output current. It's very easy. So you just take 540 millivolt divided by 27 ohm. 20 milliamp. That's it. This is the answer. Why? Why 20 milliamp is the maximum output current? Let me explain this to you. It just reminds me of when I was a college student. I never got the chance to learn this. No one taught me this. I learned this when I was a teacher. Okay? So, just a little bit sharing. Okay? The best way to teach is to learn. And for you, the best way to learn is to teach. So if you learn something today, if you learn something through this video, you can also teach others. So let me explain this to you, okay? It's not a magic. So you can do this. So I'm very confident that you will learn this today. Okay? You can harness this. The concept, how to calculate. So just listen carefully. Let me explain. Very logically, okay? So let's say 1 million. 1 million. And then what? 27. So focus on the VB1, okay? So 27 millivolt. Then what? Because 0.027 volt is too small. So the Q1 still sleep, right? Still off. Still off, right? So what about 2 million? 2 million. Then 54 millivolt. 0.05. Too small. Still sleep. And then, then 10 million. 27, 270 millivolt. 0.27. Still too small. Keep sleeping. Until let's say 19 million. What? 19 million. It's the 513, right? Did I get it right? Yes, 513 millivolt. 0.5. Okay. So still sleep, right? But okay, I see a light. So it's, and then still cut off, right? But it's close. And then what about 20? Totally wake up. Wake up. So 20, why? 20 times 27, 540. It's 540. Turn on. So suddenly, all of a sudden, the transistor on. And then what? The Q1 turn on. Wake up. And then what? Then what? Then locked. The current is locked. Why? The current is fixed at 20 milliamp. Why? The best way to explain why it's locked up, is to assume it's not locked. So let's say if you can manipulate the low current and let the low current get up a little bit, increase a little bit. Let's say if we can go to the 20.1 milliamp, a little bit, just a little bit, and then what? The VB will increase. Just watch carefully the animation, okay? So VB increase, then what? Then the current will goes up. What current? IC1. The green current will goes up. Because IC and the VB goes up exponentially, okay? And then what? Then watch the red node. Because the current from the top is the constant current source. So when the green current goes up, and then the base current, the blue current, IBN, has to go down. And then what? The emitter current of QN has to go down. And IL come from the emitter current of QN, from the top. So the IL have no choice, have to be pulled back. All right? So let's do this again. You can stop, you can pause and take note, okay? Because this is very important. So IL goes up, VB goes up, and the IC1 goes up. And then what? Fix, the current is fixed. So one goes up, the other one has to go down. And down, emitter current goes down, and supply to low current goes down. Okay? So it's hard to change. Even you want to change it a little bit, there's a force pull you back. What kind of force? Even you want to change it a little bit, increase a little bit, and there's a force pull you back. What force? A negative feedback mechanism. Okay? Pull you back. So it's hard to change. It's packed. It's fixed. It's now. It's pinned. What kind of mechanism? It's negative feedback mechanism. Okay? So you understand, right? Easy. Okay? And then, so now you know why. And you know what. What is the maximum current? So takeaway. Number one, you know what is the circuit. You can identify the circuit. Even I encourage you, if this is just fill the blank, just draw this out. So I encourage you to memorize this short circuit protection. Okay? I won't ask you to memorize too many things, but this is very important. So memorize the short circuit protection circuitry. Okay? So where's the collector base? Where's the emitter? So what's the relationship between the R1 and the transistor, protecting transistor? For example, let me give you an example. This looks intimidating to you, maybe. It's a 741 integrated circuit operational amplifier. Differential in, base of Q1 and the base of Q2. And the single ended out. So now you know what happened. So what kind of upstage is this? It's a class AB upstage, but with a variation. What variation? This. What's this? What's this? Q15 and the R6 serves a short circuit protection circuitry. And even you know how to calculate the maximum supply current, maximum output current. So number 2, the second takeaway, you know how to calculate what is the maximum output current. What is the maximum output current? It's very simple. It's VB on divided by the short circuit resistance, the protection resistance. Number 3, and you understand the magic, the reasoning, the mechanism behind this protection. What mechanism? Negative feedback mechanism. Okay? So identify the circuit and then maximum output current and understand the magic, the reasoning behind the protection. This is the end of the video. I hope you really learned something and very confident about handle this kind of variation in a class AB upstage. Thanks for watching.